From the research, the question is asking for the percentage purity of various brands of 0.100 gram aspirin tablets, specifically Bayer, Ecotrin, Equate, Genke, and Tesco. The percentage purity is determined by measuring the mass of acetyl salicylic acid present in the total mass of the tablet. This is done by using a back titration method with 1 mol dm³ sodium hydroxide and 1 mol dm³ hydrochloric acid. By using the formula given, purity percentage of each brands are determined and values are put in table 4. As you can see, results shows that aspirin tablet from the brand Bayer has the best percent purity, about 90 to 99.09%, which means it is the safest final product. In the introduction, we knew that the user shares personal experiences of using aspirin tablets for addressing most of their fever or pain-related issues. However, user expresses confusion on the effectiveness of the many available brands. To make an informed decision, user intends to examine the percentage purities of aspirin tablets from several different brands. By comparing the percentage purities, user aims to determine the proportion of acetyl salicylic acid present in the tablets of different brands, allowing comparison of their potential effectiveness in relieving pain. Because of that, user has chosen to examine aspirin tablets from several brands like Bayer, Ecotrin, Equate, Genke, and Tesco. These brands is selected due to the availability at the user's local pharmacy and their widespread global usage. As a result, this analysis will help the user choose the most effective brand to use. Next, I will be explaining about aspirin. Aspirin is one of a group of drugs called non-steroidal anti-inflammatory drugs, NSAID. It is also known as acetyl salicylic acid, a medication used to treat conditions including headaches, muscle aches, menstrual cramps, as well as fever symptoms like cold or flu. Aspirin works by blocking prostaglandins, which is a substance produced by the human body in response to injury or illness that are causing pain and inflammation. Despite its benefits, long-term use of aspirin, especially in big doses, can cause ulcers and bleeding in stomach. Some may also experience allergic reactions, and therefore it is best to seek guidance from a professional healthcare before using aspirin.
8. So, move to the methodology. First, standardization of the sodium hydroxide solution, which is NaOH. So, it is essential to standardize the sodium hydroxide solution. This is involved titration and known as a concentration of NaOH against a primary standard acid, such as potassium hydrogel pentolate, which is KHP. Next is the titration. Firstly, titrate the sodium hydroxide solution into the aspirin solution. So, it reacts with the acetyl acid, which is aspirin, in the solution, and forming sodium salicylate and acetic acid. The solution will be acidic due to the presence of aspirin. So, the detection by continuing adding the NaOH solution until the permanent color change occur. So, the color change from colorless to a faint pink indicate that all the aspirin has reacted and the solution has become slightly basic. Next, let's move to the equipment and the function. First, we use the analytic balance. This is used to accurately weight of the aspirin tablet before crushing them, and it ensures the mass of the tablet for calculating the percentage purity. So next is volumetric flask. The volumetric flask used to prepare the solution of non-concentration. It is also to dissolve the crushed aspirin tablets in a specific volume of solvent to make the aspirin solution. Then we use burette and the burette stand. The burette we use as a deliver precise volume of a titration solution into the analyte solution, which is aspirin solution. So the burette then we use to support the structure that holds the burette vertically in place during our titration. So next is pipette. Pipette used to transport a measured volume of liquid. This is ensure accurate and precise delivery of the aspirin solution into the conical flask for titration. So, for the conical flask, we use a reaction during titration. We use as vessel during titration. So, because of the conical shape allows for easy swirling for the solution during the titration. So next we use a few drops of indicator. The indicator is a substance that changes color to indicate the endpoint of the titration. Then, of course, we use sodium hydroxide solution, which is NaOH, to titrate solution, which is react with the aspirin in the analyte solution. So let's move to the procedure. First, prepare the sample. Start by crushing a known number of aspirin tablets into a fine powder. Then measure out the specific mass of the crushed tablets. This mass will serve as your sample for the titration. Okay, so next is dissolve the measured mass of aspirin tablets in a suitable solvent. We use the ethanol in this purpose. And ensure complete dissolution of the aspirin in the solvent. Step 3 is standardization of the sodium solution. Before starting the titration, ensure the concentration of sodium hydroxide solution is accurately known. This is typically done by titrating a known concentration of sodium hydroxide against a standard acid solution like potassium hydrogen petallate. Okay, next step is titration. Transfer a known volume of a dissolved aspirin solution into a flask. Then add a few drops of suitable indicator like phenolphthalein to the solution. The aspirin solution will react with the sodium hydroxide solution in a neuralization reaction. Slowly add the standardized NaOH solution from a burette into the flask while stirring. The addition of the NaOH will cause the solution to change color due to the indicator. The color change indicates the endpoint of the titration, where all the aspirin has react with the sodium hydroxide. Then, calculate using the volume of concentration of the sodium hydroxide adding during the titration, and calculate the number of the moles NaOH that react with the aspirin. After the calculation, compare the number of moles of aspirin calculated in the previous step with the theoretical maximum number of moles of aspirin that could be present in the sample. This theoretical maximum can be calculated based on the molecular weight of aspirin and the known mass of the tablets used. Divide the actual moles of aspirin by the theoretical moles and multiply by 100 to get the percentage purity of the aspirin tablets. Next is the quality control. Just repeat the titration procedure multiply times with different tablets to ensure accuracy and reliability of result. So the last step is reporting. Finally, report the average percentage purity of the aspirin tablets along with any relevant details of the experimental procedure.
And then we organize the data that we're going to use for conducting Q-test and t-test in a table. In conducting Q-tests, the data need to be organized from smallest to bigger value. In this set of data, 77.47 selected as suspected value because it gives higher value compared to 93.36. The Q value 0.34 is calculated by subtract the suspected value 77.42 with nearest value to it, which is 82.88, and then it will be divided with number of highest value 93.36 that will be subtracted with the lowest value 77.47. Based on the Q-test table and our Q value that have been calculated, at 90% Q calculated is less than Q table, hence the value 77.47 is retained. It also the same for 95%, and 99%, where the Q calculated is less than Q table, and the conclusion 77.47 value is retained. For t-test, we use the formula for confidence limit, where it includes mean, degree of freedom, and standard deviation. At first, mean, which is 85.70, and standard deviation 6.218, is calculated using its own formula. And then we will refer to the t-test table for degree of freedom, where the value that we use is in the fourth set of data. As you can see here, at 90 degree, the confidence limit is 85.70 plus minus 0.15. At 95 degree, 85.70 plus minus 0.20. And lastly, at 99 degree, 85.70 plus minus 0.33. The table on the left is the t-test table that we refer to know its degree of freedom. Now let's see on the discussion part. Dickson Q-test, also known as the Q-test, is a method for identifying outlier, so we can remove it to ensure more precise statistical outcome. For this data, the calculated Q value 0.34 is less than the critical value from the Q-test table for the given confidence level at 90, 95, and 99%, and also consider the sample size. This suggests that the suspected data point is not statistically different enough from the other point to be considered an outlier. As a result, all data points, including the suspected outlier, will be utilized in further statistical calculation. Now let's shift our focus to the t-test. The t-test is a statistical method used to assess whether there is a significant difference between the means of two groups and to understand the relationship between them. For this data, the calculated d-value didn't exceed the critical value at 90, 95, and 99 degrees. This indicates that the difference between the group means is not statistically significant. We can assume no difference between the means of the two groups.
In short, researchers found out that among the 5 brands of aspirin tablets, Bayer's aspirin tablets has proven to be the most effective for pain relief. This is due to the high percentage purity, which aids in providing more immediate relief. On the other hand, Gencare's aspirin tablets were found to be the least effective due to the presence of other ingredients. However, the reliability of these results is reduced due to high percentage uncertainties. These uncertainties could have been caused by various factors during the process. Furthermore, the standard deviation of the percentage purities indicates the uniformity of the distribution of acetyl salicylic acid in the tablets of the same brand. This is an important factor as it indicates the effectiveness of each tablet. And lastly, the results accuracy and the presence of systematic errors during the experiment cannot be identified due to the absence of theoretical values.